we got caught up. We're caught up to here, I think. And now it's just a matter of canceling. I mean, I guess you have to say that x cannot equal -8 or 1, but you got a bunch of cancels. That cancels that, that cancels that. So end up getting this negative. This negative you can't forget about. Negative x plus 5 over 9.
All right, on to number 25.
25 has a lot going on. It's you got to factor 3 of the 4 positions. All right. So top left here becomes x minus 4, x plus 4. That's difference of squares. Top right becomes x, looks like it's plus 9, x minus 10. No, it's the other way. It's x plus 10, x minus 9. This 9 minus x, you're going to make it into x minus 9 with a negative out in front.
Mm-hmm.
And then you got x plus 10, x plus 4. I never got to make this point in the previous lesson, but it's really important here is sometimes if you don't know what it factors into, you gotta assume it's going to factor into some stuff that's already there. Like they're going to cancel out. So it's not like you shouldn't be surprised that it's a matching one. Usually it is. So now we just start canceling. We got x minus 9, x minus 9, x plus 4, x plus 4, x plus 10, x plus 10. So we're left with x minus 4 over -1. We wouldn't leave it that way. We would apply that negative. So it'd be 4 minus x.
All right. Let's finish this up with number 26.
This one you have to factor all 4 positions. This is I guess truly the synthesis of them all. So we got 10x, x minus 2 over 40x squared over x minus 2. Bottom becomes x plus 5. And the top is 16x squared, x plus 5. So a lot of things are going to cancel. I guess x again cannot equal 2 comma negative 5. So now we get a lot of things cancel. No.
After canceling?
You want to keep canceling. Like this x squared goes with this x squared. Okay. 10 into 4 puts a 4 down here. 16 divided by 4 puts a 4 up here. 4/6 becomes 2/3. And then there's still that x left over.
All right. Let's move on to solving square root equations. Okay. Worksheet. This one we'll just do 1 through 10.
This is formatted really poorly. Probably because it was shared as a Google Doc and the things were.
Oh yeah, that's why I sent you a screenshot in our email.
Oh, you did? Okay. All right. Yeah, that we can do this. Okay. Number one says 3 equals square root of b minus 1.
Yep.
Okay, so how do you undo a square root? Do you recall that?
Don't you square on both sides and then
Square
get 9
both
equals
sides.
b minus 1.
Yep. So you get 9
Then
equals
add 1 on 1. B equals 10.
Right. Now it says check for extraneous solutions. Here's what that means. You're supposed to take your answer every time and substitute it back in. Now what's going to happen is that eventually you're going to get 2 answers, so it'll really be two paths here, but this is correct, so you don't have to worry about that. Just because you get an answer doesn't mean it's correct. Just because you get 2 answers doesn't mean that one is wrong and one is right. They could both be right, both be wrong. There's lots of possibilities. So try to not, like I keep saying this, jump to conclusions. If I'm being a little bit critical of you, Jack, on this, I mean this in a positive way. You're really good once you're shown how to do something. You're still learning how to know how to make that first step. So just don't jump to those conclusions until you feel really solid about what you're doing. So here you're going to square both sides. You get 4 equals x over 2. You multiply both sides by 2, so x equals 8. And then we can try that back in the original here. So if you go back to the original, 2 equals square root 8 over 2. Does 2 equal the square root of 4? 2 equals 2. Yes.
Yep.
All right. I gotta just grab some coffee here. I want you to try the next 2 on your own, and I'll be right back to check on you.
All right. Sounds good.
I agree last night. Yes, girl. I feel forward. Yes, what happens so yes. I have 8.
All right. Hey, Jack, I'm back.
All right. I got -4 for number 3, and I'm still working on number 4.
Okay.
I end up getting x equals -4, and that plugs into it and works.
Okay. So 5 is going to be really similar. So why don't you give 5 a try? And then 6 starts a new kind of set of
Equations.
Yeah.
5 minus 3 squared 25 minus 3 plus 3 plus 3. 5 equals 28. And 28. All right. All right, on to number 6.
Okay, so number 6, let me snip it in. When you square both sides this time, you end up getting a so the previous problems were like always like the square root equals a number. This time it's a square root equals a square root.
Mm-hmm.
And all it does is when you square both sides, you get it down to a linear equation. And you already know there's 2 lines, they either intersect in a point or they don't intersect at all, or they could possibly be the same one. So that's why I said there could be lots of possibilities here about what you get in terms of the answer.
I simplified it out and got m equals 8. Now I got to plug it back in. So it works. I plug it back in. It turns into 100 equals 100.
Yep.
On to number 7. Let's see. 8k equals k, square on both sides. 8k equals k squared. What do I do from here?
So the difference is now it's like we really should have done 8 first, because 8 is like 6. If you want to do 7, we can. I was just doing 8, 9, and 10 first, and then coming back to 7.
All right.
So I'll do 8 here, and you end up getting. You always kind of get it down to something that's pretty manageable here. You get 9 minus b equals 1 minus 9b. So you end up getting 8b equals -8, so b equals -1.
So I have to plug it back in though.
You don't have to. You should on a test, because you're trying to guarantee that you get it correct. But you know, for me, for this assignment, no, it is good practice. But I mean, I think you're trying to get through a number of things now, so I don't want to overdo it.
All right. Number 9. All right. I got 1 minus 3x. All right. Now we go on to 10. 3k minus 11 equals square root 5 minus k, square root on both sides. 3k minus 11 equals 5 minus k. Let's see. Plus k plus 11 plus 11. 16 equals 4k. Divided by 4 divided by 4. K equals 4. Plug that back in. We get 12 minus 11 equals 5 minus 4 squared. That's true. All right. Now we can go back to number 7.
Yeah, so this is another variation on these. There's only so many of these, but this is the square root of something equals a variable or a linear expression. So you still square both sides, but like you said, you get 8k equals k squared. Okay, and this is often where students are like, I don't know what to do, or they end up doing something that's totally wrong and wouldn't be good to do. But if you move this 8k over, it's 0 equals k squared minus 8k. Or if you prefer, you can write k squared minus 8k equals 0. And you're solving this, so you can factor out a k. And you know that either k equals 0 or k equals 8. So this was actually the only problem on this list that had 2 solutions. 2 is when you generally have to, check them.
0 equals 0, so 0 works. What about 8? Let's see. 8 times 8 is 64. 64 squared is 8. 8 squared equals 64. Wait, 8 doesn't work. Should be only 0 that works. Is that true?
8 works as well.
8 does work? Okay.
8 works because you're doing square root of 8 times 8 equals 8, question mark, it's kind of a question mark. Is the square root of 64 equal to 8?
All right.
Yes.
I want to move on to composite functions.
Okay.
It should just be 1, 3, 5, 7, and 9.
Okay. 1, 3, 5, 7, 9. Okay. All right. Making good progress.
That's great. All right. Now we're at number 1. Oh, God.
Okay. So the bubble here, f bubble G means f parentheses G of n. It means taking whatever G of n is, which in this case is 3n plus 3, and putting it back in for n in the previous problem.
Mm-hmm.
So the f bubble G of n, f bubble G of n, and this is all proper notation, which is equal to f of G of n, means to do the following, means to take f of n and take that 3n plus 3. This is now 3n plus 3, so you're going to put 3n plus 3 in here. So it looks like this. F of 3n plus 3 equals 2 times 3n plus 3 plus 3.
All right, 6n plus 6 plus 3.
Then you need to simplify 6n plus 9.
Is that it?
That's it.
All right. Number 3. This one's just f of n squared plus 3 times 9. Wait, what? How do we do this one?
Give me just a moment to get caught up to you. Just behind, of course. Okay, so f of G of A. What is G of A? What is G of A in this problem?
G of A should be a minus 2 times.
No. G of A is A minus 2. So A minus 2, you're taking that, and wherever you see an A, you're plugging that back in.
Oh, okay.
So f of G of A is the same as f taking this A minus 2, because that is G of A. G of A is A minus 2. And wherever you see an A, you're plugging it back into itself.
All right. So 2 times
Because now you have to expand this binomial. This is where if you haven't done it in a while, you can easily write the wrong thing here. There's 3 terms: a squared minus 4a plus 4. We're just continuing to simplify here, and then you start combining like terms. So you get 2a squared minus 7a plus 6.
All right. On number 5.
Number 5. Oops, I grabbed the wrong one here. New. Okay, so this one is F bubble G or F composite G, but it's a number now. So there's 2 approaches to this one. The first approach is to do like we just did in the previous problem, which is you just say, well, it's F of G of n. Like you do it with the functions. So option 1 is to do it with the n, and then the second step here, or you n and then you put the number in.
Mm-hmm.
The second option is to find f of G of 9, which means you're first going to find G of 9. This is what most students do, meaning they just go to here and they find G of 9. And then you take the output of that and you put it into F.
Oh, okay.
They both are the same, but this is generally the predictable outcome here, a predictable one. So 9 squared is 81, plus 3 is 84. That's G of 9. And then F of, and then you have to take that number, 84, is minus 2 times 84 plus 3.
All right. Negative 168 plus 3 equals negative 165, right?
Yeah, negative 165.
All right. On to number 7.
Number 7. Okay. All right. So this one, this one is very uncomfortable for students because you're used to having 2 functions. Now you only have 1 function, and you're doing it with numbers. So if you only know the inner part here, if you could only take a step on that, how do you find h of -5? What does that mean in the context of this? Just the inner part. What is that?
Isn't that when you put -5 in the negative
Exactly.
3x minus 5?
So you end up getting a 15 minus 5, so you can end up getting 10. Okay. So literally, h of -5 is 10. So it's saying find h of whatever h of -5 is. So this means this outermost
10.
part means to find h of 10, because that's what we just found. So it's -3 times 10 minus 5.
Equals -35.
Yes.
All right. Last one, number 9.
Okay, so you give this a try on your own. It's exactly the same as the previous problem. It's just the different notation. You're going to find f of -1, and then you're going to use the result of that, and then find the result of that by plugging into the function.
-8.
Yes.
Perfect. I don't know what that one. Let me pull up the other stuff. All right. Send you a picture of these next problems. They should be sending shortly.
Hey Jack, did you get bumped from the room?
I did not.
Okay. All right. You're still sending some over? I haven't seen anything come in yet. Okay, there it is. All right.
There we go.
Okay. So we got 5.1. We've done this. I mean, I can pull up the notes if you want. What we've
can you pull them up real fast? I don't think we went through all of them. I think that we went through most of them.
Well, we could. I mean, we can almost just go through them just as quick. But we've done all of these all the way up through 40, whatever. I mean, they were probably in separate lessons.
Oh yeah, they were.
But these are all there. So I mean, we can do whatever you want to do. That's not a problem. It's just I definitely don't want to.
Yeah. Can we pick up at number 55? I think that's where we left off.
Which number? I'm sorry.
55.
55. Yeah. Okay. Let me snip that in. Okay. The process of finding an inverse is the first thing you do is you switch x and y. So y for x, x for y. So this becomes x equals 3y minus 4. And then you solve for x. I'm sorry, you solve for y. Sorry, solve for x. So to do this, you end up getting x plus 4 equals 3y. You end up getting y equals x plus 4 over 3.
All right. There we go. Next, we move on to number 57.
Yes. Okay, so same thing. You switch x and y as your first step, and then you want to solve for y. So you're going to subtract 1 from both sides. And then this time you're going to take a cube root. So that's, you undo a cube with a cube root.
Wait, do we have to put the? Don't we have to put we give the domain and range of f and f negative 1?
So far, these have all been minus infinity to infinity for both. The domain and range.
Domain range.
Right. Yeah, that we're not up to one where there's any issues. 59 does not have an inverse, so that's why we're gonna hopefully cover that here, so I can explain why that is or whatnot. Okay, 59 is 59, right?
Mm-hmm.
So 59 does not have an inverse because when we graph it, you'll see that it does not pass the horizontal line test.
All right.
So see how the horizontal line test, it hits it 2 times?
Yeah.
So that means it has no inverse.
All right, can we move on to number 67 to 69?
Yep. 67 is a kind of closer to an exam quality question. When you switch x and y, you get you have a bit more work to do. So there's really kind of a 0th step. And sometimes I do that just because I forget that really this is the first one, but you really change y and f of x, they take each other's place. So this is really y equals 4x over x plus 1. It's pretty, it's pretty, it's not a big deal, but here you have to again switch x and y. So x equals 4y over y plus 1.
Okay.
So now this is where it gets tricky. To solve for y, you end up having to clear this fraction. So you multiply both sides by y plus 1. So you have y plus 1 times x equals 4y. So then you distribute this x over here.
Equals 4y.
And then you move. You're gonna get the y's on the same side. So I'm gonna move the xy over 4y minus xy, and then you end up factoring out a y over here. So you get 4 minus x on the right. And then you divide both sides by 4 minus x. So y equals x over 4 minus x. This is one of those times where that negative on the bottom can be factored out. So you might actually see the answer written like this.
Mm-hmm.
And that's okay too. Like these are both correct. Just depends how you want to do them. You said there was another one in here, 69?
Yes.
Okay, good, because it's kind of the same thing. It's, you gotta do a few things to get it where you can actually find the inverse here. So all right. Okay, so again, you want to make y as f of x, and then you switch x and y. So x equals 1 minus 2y over 3y. So you multiply both sides by x, so you get 3xy equals 1 minus 2y.
All right.
So now you got to get the y's on both sides. So it's going to be 3xy plus 2y equals 1.
All right. Go factor out a y, right?
Yeah, and then you get y times 3x plus 2 equals 1.
Y equals 1 over 3x plus 2. Perfect. After we go on to number 79.
At 79?
Mm-hmm.
Yes. Okay, so we're just evaluating the expression. This one I know we haven't done yet. For 79, f of x equals x cubed, f of 2 equals 2 cubed. So that just means f of 2 equals 8.
All right, can we do that through 84?
Sure. So f of 0 equals 0 cubed, f of 0 equals 0. 81, same thing. We have f of minus 2, which equals minus 2 cubed. Really important that you put that in parentheses. It becomes negative 8. All right, so f inverse of 8. Okay, probably for you, the best thing to do would be to find the inverse of the original function. So we have f of x equals x cubed. There is another way to do this, but let's just assume for a moment you're finding the inverse. You switch x and y, like I've done here, x equals y cubed, And then you take the cube root of both sides, so y equals the cube root of x. So now this is f inverse of x right here. So f inverse of x is the cube root of x, which means that if you're finding f inverse of 8, you're just
put
putting
8 in for x.
Yes, so you end up getting 2 for that. Try to do the last 2 on your own.
I got 0 for 83 and -2 for 84.
Good, those are both correct.
I think that was everything I wanted to work on today, Matthew.
Okay, sounds good. These videos are actually taking a while to process on the Zoom side, so I'll get them out to you as soon as I can. Probably in the next hour, you'll see all these. You'll see 3 emails from me.
Perfect. Thank you, Matthew.
You're welcome. Have a good day. Thanks for scheduling. Okay, bye now.
Bye-bye.